with Glenn Fletcher, president of EOS. Glenn, overall, this industry has migrated slowly from a curiosity from a hobbyist endeavor to a desktop prototyping technology, and now we're seeing increased interest of additive manufacturing as a true mass production technology, like a machine tool.
Sure.
Is the future of this industry in the factory floor or in the design office?
Well, I think you have to start at our origins. We've been in business almost for 30 years, so additive, and we were one of the sort of early adopters of additive manufacturing as a technology. So our owner and founder bought into additive manufacturing quite some time ago. It took us 20 years to sell the first 1,000 systems. It took us 5 years to sell the second 1,000 systems, and almost on our 28th birthday we passed 3,000 systems. So you can tell by that we are condensing the timescales all the time. And as of now, we're scaling production to be able to supply our customers with 1,000 systems per year. So it's accelerating fast, but it's actually only really started to exponentially grow over the last few years. And one of the reasons for that is, of course, it was associated only with rapid prototyping in the past, and now it is finding it's going through the transition into the production environment.
Now, manufacturers are traditionally conservative design, conservative in capital equipment choices for good reasons. Are we moving into a paradigm now where we start to think about parts designed to be additively manufactured?
We have to think about parts designed to be additively manufactured. Too often, people who are making their assessment of additive manufacturing come to us with a traditionally manufactured part. It's either cast, or it's injection molded, or it is traditionally machined, milling, turning, grinding, all of those things. And that's not really the right approach. You have to start with a functional objective, a functional imperative in mind. And that could be lightweighting, that could be optimized topography, meaning fitting it into a tight space, or it could be combined functionality. But if all you try to do is replicate what you're doing today, and with additive manufacturing, creating something that looks the same and does the same, then it's probably not going to be a great fit.
Now, before computers, all manufacturing was iterative. It was try something, it breaks, redesign it, make it stronger, better, optimize your process, optimize your part. Then with computer technology, we developed the ability to simulate or to use finite element analysis, various technologies to try and make the part better at the design phase before we cut metal. But now with additive, in a way, we could go back to the original form of try it, see if it works, and iteratively design our way to part perfection. Do you see, will simulation coexist with this sort of iterative try and 3D print your way to success?
I like to think of it this way. In the past, we used to iterate to mediocrity. Now, with additive manufacturing, you can iterate to excellence. So what I mean by that is, if you take that previously accepted idea of design for manufacture, you would always try to find ways of improving the manufacturing process through design, rather than improving the function through design. Now, reiteration costs really very little. You know, it is a digital process. We can test and we can do a lot of things even before we put it in the machine. But that digital format is there, and it can be adjusted, and the cost of that adjustment is minimal, and the level of complexity is almost free. So the more previously, when we were designing for manufacture, complexity cost a lot of money.
Yes.
Now complexity is, as I say, almost free.
Better parts, lower cost parts, and more cost effective parts. This is Glenn Fletcher, president of EOS.